Hi guys, thanks again for visiting us at RS Aquaculture. In this episode, I'll be going through how do we connect the equipments together and the piping system that's used to do it, and how does the water flow in between systems and boxes, as well as what is the piping configuration. So stay tuned. In the previous episode, we have actually gone through the process of arranging all of this equipment, mainly the sand filters, water retention tank, pump skid, UV filters, and how the boxes, right? So if you missed that, please revert back to the second episode to check out more details as well. So for those who have already downloaded the free ebook, make sure that if you've gone through the dimensions and understand what are the issues or what are the basis for setting certain dimensions or putting some of the layer in a certain manner. Right, so in this episode, I will start off with the pipings first. So let's first focus on the crab houses first. So as you can see, it consists of two pipings, right? So these are what we call the inlet pipings, right? So the inlet pipings are responsible for bringing water flow into the boxes. So each of this is connected over here. So typically this can be a 2-inch pipe and it's reduced into a 25 mm or half an inch pipe, right, in which water will sort of accumulate in the boxes, and we have a stand-on pipe in the boxes. For those who are not familiar with this, you can probably check out my other videos, right? And water will actually be flow out from the outlet pipe. So as you can see that the topmost board doesn't have outlet pipe because there's nothing flowing out from the box above, so the outlet pipe will only start after the second row, right? And for those who have actually tuned in last week, you have actually also seen that we actually purposely intentionally leave a canal, or what we call a void space, between the cement portion. This is to accommodate the lowest piping portion, right? So as you can see, water will tend to flow into the drain. So obviously the drain is doesn't only collect the water coming out from the outlet from 2 rows or 2 columns, it does for the whole system. So make sure that your cementing will allow water to flow from all the way to the last block to the front. Okay, so for our farm, we actually created some sort of gradient over here, just a slight gradient to facilitate water flow all the way out. So normally, to top up some of the chemicals like calcium or salt, we usually just drip over them over here and allow the water to slowly bring out the salt or calcium particles back into the systems, right? So as you can see, what happens when the drain collects the water is you will have a place that it will actually perform what we call fall into the first retention tank. So the retention tank over here is actually simply just a very square retention tank, right? So I will just ignore these 2 holes for the moment. I'll explain this in a little bit. Right, so water will flow it over here, and the dimension over here is about 1 meter by 1 meter. So you can also find this in our ebook, right? So the first piping that you probably have to assemble is this piping, right? So I'll just show it at the moment. Okay, so this piping is the usage of this piping is pretty simple. So the water, once it enters the first retention tank, so let me just reorientate the view so you can see it a bit clearer. Okay, so the first purpose is for this water to be picked up by this pipe, right, and it goes through all the way to the first pump. Right, so this is the first pump that you see over here. Okay, so for those who have followed our last episode, this is actually where we have our water storage. So normally you have actually a valve that is installed over here, right? So this is to make sure that in the event that you do not need any water, this can be turned off, and when you need to top up water, this can be turned on to allow quick suction of water stored into the system, right? So it gets sucked into the suction part of the first pump, right, by picked up all the way. So make sure that the pipe actually starts to the pipe all goes all the way down, and at the bottom of this piping system you usually have a check valve, right, to prevent the water from backflowing. Okay, so that's what the pump do is it then pumps the water directly into the sand filter. So usually it goes into a multi-port valve first. So for in this case, we're actually simplifying the sand filter without any multi-port valve, right? So it goes into the sand filter, gets filtered, and then using the remaining energy from the sand filter, what happens is we actually connect it to aerate our biofilter. Okay, so for our side, we actually have not omitted the drawing of the biofilter to just keep it a bit neater, and at the bottom we're actually using a venturi system. So this one will actually depend on how you intend to aerate your venturi system, and that's case by case, right? So this is the first part of the piping, right? So in which you suck up water, pass through the sand filter, remove the solids, and use it to aerate the biofilter. Okay, so the next part really is for ultra UV filtration and how do you pump the water back into the boxes. Alright, so this is how it looks like. So we actually have a pump which are also sucking from the bottom, and it connects to the suction part of the pump. And then what it will do is it will actually gets connected over to the UV filter, get passed through and radiated with UV light, right? And then it will then be connected back into the inlet boxes, right? So obviously you can see that how water is being recycled using a series of piping. Okay, and so why do we need these two holes is because we are actually using two pumps at the moment, and the flow can be quite hard to equalize because one pump will have to pump through a sand filter, whereas the other pump has only simply needs to go through a UV filter. So if you do not have this equalizing channel, so what tends to happen is the water level at this point, right, will tend to overflow because given the water is flowing back faster, then it can pass through the sand filter, right? So what we tend to do is to ensure overflow section here so that you prevent the water from overflowing here, and it will instead bypass some of it to the second retention tank. So obviously it reduces some of the efficiency, but it's a safety measure to ensure that we do not lose water or we do not have any overflow situations. Okay, so this is how it looks like when it's when you have assembled a piping systems. So next I will try to explain some of the additional key dimensions you have for navigating the space. Okay, so here I have a full-blown diagram of all the boxes all assembled together, and this is how it looks like, right? So sometimes it's also common to have some of the water that is being used as one of a common header to connect to a flexible hose to top up anything with salt water. For our side, ours are actually on over this side, right? But it really matters. It really depends on where are you trying to tap off a common header to use some of the salt water. Right, so for those who have been following, so our first episode on providing the adequate clearance for walking. So in that episode, we actually showed that the distance between the light bricks is about 0.95. So as you can see, the distance between the cement blocks is about 0.95. But once we start to put more boxes, right, what we realize is the actual clearance between the box is actually smaller than that, and it's only about 65 cm apart. Right, so the downside of having too small of a clearance is that you will not enable efficient working. For example, 65 cm is only really enough if you have one guy that is working at the moment. For example, if one person is to work over here, you might find it hard for another person to sort of reach into the inner box to retrieve some of the crabs or start feeding some of the crabs. So for us, I think 0.7 is just nice if you have one or two guys that are working on the farm. But if you have more guys than that who are simultaneously doing feeding and retrieving our crabs, and there's a lot of movement in the crab farm, you probably need to widen up this space to about 1 to 1.2 meters at least to facilitate easy movement. All right, so as you can see from this diagram, another key point for walking is how do you get from this part of the farm over to this part of the farm. So obviously you will tend to try to walk over here. So what I realized my staff always doing is they will try to traverse over here using this narrow walkway and try to hop on over to this side, which can be quite dangerous if you do it too often. So what we recommend is for people to walk all the way over to this side. So try to make sure that if you are able to move your sand filter a bit to the front, I think that will also facilitate more space for you to walk around here, so that will minimize some of the walking that is required to work efficiently. Alright, so in this episode, I've actually shown you how does the piping actually connected together. I've showed you some of the consideration with regards to a walking space that is required here and over this side, and why do you need overflow via over at this point, right? In the next episode, I'll try to show you how does all of this system actually fit in a 70 by 20 feet shop lot, right? And and that will give you some idea on what are the additional areas that I need for storage, for quarantine, and etc. Okay, so for those who haven't downloaded the ebook yet, we actually gave out a free ebook in which we have all of this dimension, all of this clearance, all of this pump positioning, how big is this area. All of it is available in the ebook for you to download and reference, and most importantly, guide you in designing your farm. All right, so I'll see you guys in the next episode. Stay tuned.